Hello and welcome to this last video in our lecture on remote user authentication. In this video, we attempt to describe protocols that support both mutual authentication of both parties and the secure establishment of a session key. So in the previous video, we described two protocols, one that used encryption and one that used signing. And neither one of them could satisfy both of our goals here. So to try to satisfy both goals, we're going to try and combine those approaches, and we're going to do so in two different ways. First, we're going to try to sign and then encrypt, and then we're going to try to encrypt and then sign. So in the first proposal here, the first message will be the same as before. Alice is going to generate a nonce. She's going to send that over to Bob together with her identification information. Bob is going to receive that nonce. It's going to generate a random key K, will concatenate the two, and here it will sign first, which means encrypted with his own private key, and then it will encrypt the whole thing by encrypting it using the public key of Alice. So Alice will receive this signed and encrypted message. She's going to be able to decrypt it using a private key, and then she's going to be able to verify Bob's signature by decrypting this with Bob's public key. And in the process, she will both authenticate Bob, because Bob was the only one who was able to encrypt the challenge she sent him, and she will get the original copy of the key. Now, to authenticate herself to Bob and to send the key securely back to him, she will first sign the key and a version of the original nonce using her private key. So she will do sign then encrypt. Here is the signature stage. Then she will encrypt using Bob's public key. So Bob is going to receive this signed and encrypted message. He will be able to decrypt it using his own private key. Then we'll be able to verify Alice's signature. So Alice will now be authenticated to Bob. And then he will be able to check that Alice is the one who received his key and was able to send it back. So this is how this first version of the protocol works. A second version, where we encrypt first and then sign, starts the same way, with Alice sending a challenge, a random number or nonce to Bob. In this case, Bob is going to encrypt it first using Alice's public key together with a random key that he generated, and then he's going to sign it using his own private key. Again, Alice is going to receive that encrypted and signed message. She's going to be able to verify the signature and undo it by decrypting it using Bob's public key. And then she's going to be able to decrypt the inner message using her own private key and therefore get access to the session key. Then to authenticate herself to Bob, she's going to first encrypt both the nonce and the key using Bob's public key. That's for confidentiality. And then she's going to sign the whole thing using a private key. So Bob, receiving this message, can check that this actually came from Alice and that she's the one who received the key and was able to encrypt it for him. So again, in this case, it appears that both parties are authenticated and the key, the session key, was shared securely. So I really want you to stop the video, and this is probably the most important time to do so, because this is probably the most complicated protocol we've seen so far. It uses, or it does, mutual authentication. It establishes a session key in a secure way, and it uses a nonce to avoid replay attack. So the two questions that I want you to think about is one of these protocols more secure than the other? And more generally, are either one of these protocols completely secure? So the answer to the first question is actually that one of these protocols appears to be less secure than the other. and this is the second one. Because notice what happens here is that what's done on the second step is a signature step. So in both messages here, the outside operation is a signature operation. Therefore, anybody who has access to the public key of Alice and Bob, which means everybody who wants to get access to them can, they can all decrypt this part. So this means that this inner part here is accessible to everybody, not just Alice and Bob. So this is not the case in this version because the outside operation is an encryption algorithm and nobody is supposed to know the private key of Alice and Bob. So nobody can get to the inner part here. So it appears then that it is the case that this protocol reveals more information than the other. Namely, one layer of the onion can be peeled back in this case. However, notice that even with access to this information, the attacker would have to be able to either figure out the private key of Alice or Bob, or they would have to break the crypto. So in both cases, it appears that to figure out what K was, the attacker would need to be able to break the public key encryption algorithm. And at this point, this is not known to be possible. So even though this appears to reveal more information, as long as public key encryption is unbroken, then these two protocols should be as secure as the other. So this is how I'm going to wrap up our lecture on remote user authentication. There's a couple leftover topics that we'll have to discuss in the next lecture. But before we wrap up, just remember that these protocols are very subtle. There are several lessons we learned throughout this lecture. One of them being that a simple modification to a protocol can have a significant consequence on its security. And I really encourage you to study these protocols and the previous ones, but in particular this one. So this is the combination of our study, and I want you to try and break them. So please let me know if you find a way to break either one of these protocols. And in the following lecture, we'll be discussing related topics on remote user authentication and then start a new topic.